Hypothesis testing. So the two main themes here are the null hypothesis and the alternative or alternate hypothesis. The null hypothesis is the default assumption, usually stating that there's no association or difference between the groups being compared. The alternate hypothesis states that there is a significant association or difference between the groups being compared. Oftentimes, we want to reject the null and accept the alternate hypothesis, and this is common language in research papers. We have talked separately about p-values, and here, if the p-value is below 0.05, the null hypothesis is rejected and the alternate hypothesis is accepted. Conversely, with a non-significant result, the null hypothesis cannot be rejected, meaning that the observed effect or difference could be due to chance, and we cannot accept the alternate hypothesis in that context. Here's a cartoon showing reality on the top and research on the side. And when our research finds that the null hypothesis is true, there's no real difference, and that is the reality, then we're all good. Equally, when we find that the alternative hypothesis is true, and that is the reality, we are good. However, there are situations where our research has found that the alternative hypothesis is true, but that's not actually reality, that's not the truth. And in that case, that's a type 1 error. In the case where we accept the null hypothesis as being true, but that's not reality, the alternative hypothesis is actually true, that's a type 2 error. So basically, type 1 error is rejecting the null when it's actually true, saying that there's no difference between the variables measured. A type 2 error is when we accept the null when it is actually false. There is a real difference between the variables. Power is the probability of not making a type 2 error. And here we see it again, truth on the top and our conclusion based on the data on the left, and correct conclusions as we've discussed, and then the type 1 error and type 2 error.